This video shows advanced modeling for Ayrshire purlins in Tekla Structures. The macros covered in this video are used for non-standard conditions. The Ayrshire cold rolled overlap 1, 2, 6 macro is for overlap systems, not for the much more common oversail system. In overlap systems, every other purlin is flipped 180 degrees, and instead of using sleeves, the purlins overlap. To use the macro, set out the purlins with alternate Tekla rotations set to top and below. Align the purlin webs. Make sure the flanges align. Use the Ayrshire cold rolled overlap 1, 2, 6 macro. Pick the rafter, then the purlins, and end the command by clicking on the scroll wheel. The profiles will show as clashing, but on site these will nest together and overlap. Typical monopitch roof systems use diagonal braces that are attached to the purlins with FB brackets. Heavy roof systems can exceed the FB bracket capacity, so in these cases the diagonal ties connect to rafter flanges. Although the macro name is diagonal tie column 81, it is also suitable for roof systems. Start by adding a work point on the hot rolled flange, where you want to put the bolt hole. Set the selection filter to Objects in Components. Then select the Ayrshire diagonal tie, column 81, macro. Pick an individual bolt at the base of a strut. Then pick the rafter. Finally, pick the point for the bolt through the top flange. The diagonal tie may look like it's clashing with the rafter, but will be okay in reality. We often use a combination of 2 or 3 macros when roof systems have skylight penetrations. In this example, we have CW channel framing a skylight, with struts and diagonal ties above and sag bars below. The best method for adding trimmers starts with modeling the CW channel directly on top of the rafter. Start by isolating the rafters using Show Only Selected, or use Shift plus Show Only Selected to hide everything else. To ensure the correct offset, use the purlin preset and change the profile to CW. Ayrshire's CW range are compatible with Z's, and use the same cleats with the same hole sizes and positions. Add the CW so that the webs are orientated for the skylight framing. Redraw the model, and check that the CW flanges are aligned with the Z purlin flanges. Split the CWs roughly to the correct position. and remove the unwanted pieces. Move the CWs as needed for the opening. Use Ayrshire cold rolled cleat 1-1-5 connections at the CW ends. Adjust the connection parameters to control the cutbacks and cleat orientations. Bracing may be required. This depends on the type of roof. Start with an orthogonal view of the roof plan. This is achieved by clicking on the Z-axis of the UCS. Then, draw construction lines, and move them to the brace position. Next, add points at the intersections between the purlins and the construction lines. For struts, use the Ayrshire non-standard anti-sag 67 macro. Non-standard macros need to have the correct parameters set before they are used. You can't change them afterwards. Pick one purlin, then the other, and then the point. Use the same Ayrshire non-standard anti-sag 67 macro for anti-sag bars. Change the parameters to sag bars. Then, pick one purlin, then the other, and then the point. Repeat as needed. To add the diagonal tie, use Ayrshire diagonal tie cleat 82. Pick the first bolt hole, then the cleat hole. Both Ayrshire shear plate to hip 8 and Ayrshire simple hip 14 can be used at valleys as well as hips. Both are simple to use by picking the hip rafter, then 1 or 2 purlins. A hidden use for these macros is that both can add connection plates for inboard systems, where purlins sit between rafters. Both macros can be used at all inboard conditions, including square cut and angle cut plates. Hips and valleys often need cold rolled bent plate, along the ridge or valley. Ayrshire can manufacture, and supply, these bent plate pieces up to 12 meters long, and with thicknesses ranging from 1.3 to over 3 millimeters. Here's one way to model the bent plate. First, make a cross-section view of the hip or valley beam. One way to do this is to add a plane across the hip beam. Then, make a view on the plane. Next, draw construction lines along the slopes, and one at the midpoint. Then, measure the angle between the construction lines. This instance rounds to 21 degrees. Add a folded plate. The folded plate parameters are leg, thickness, leg, and angle. For this instance we are using a 2 mm thick, 200 mm wide folded plate. Ayrshire supplies folded plates in various widths and thicknesses. Please contact Ayrshire for details. The fold angle is calculated by subtracting the measured angle from 180 degrees, so in this instance 180 minus 21 equals 159 degrees. Add the folded plate along the hip slope. Change the folded plate color to distinguish the folded plate from other items. Switch to the cross-section view. And change the rotation to half of the measured angle. In this instance 21 divided by 2 equals 10.5 degrees. Move the folded plate, on plane, rotation, and, at depth, settings, to arrange the piece correctly. Custom bent plate will be excluded from CAM file transfers, and Ayrshire will need part drawings for manufacturing. On Drawing Properties, set the Assembly Drawings template to CR_AYRC. Change the drawing name to Ayrshire Pressed Section, then Apply and OK. Create the assembly drawing. Open the drawing. And dimension the cross-section view. Include the angle. And dimension the bend. and both leg dimensions. To request a quote, email the drawing to sales@ayrshire.co.uk. If you need further information or technical advice, please contact Ayrshire Technical Services.